Hello everyone, I'm Sajjadur, a researcher at Kandogan Labs. Today I am going to present our work on characterizing practices, limitations, and opportunities related to text information extraction workflows. Information extraction is often the crucial first step in text analysis and used in tasks such as entity matching, knowledge-based population, and text summarization. A typical information extraction workflow requires significant human intervention in various phases. We have observed that the typical phase-based characterization often fails to capture the fine-grained user tasks and actions in each of these phases. However, understanding the fine-grained details is crucial for developing human-in-the-loop productivity tools. To this end, we conducted a study on 10 industry projects that employ information extraction. The goal was to better understand the tasks and actions users perform in each phase, identify challenges they face in performing these tasks, and obtain feedback on how to improve their experience with the existing tools and setup. So, what did we learn about their workflows? Somewhat surprisingly, we observed that in each of these phases, users repeatedly perform five classes of tasks. First, view, for example, viewing samples of data during preparation. Then, performing assessment for understanding the data domain, for example, using summaries or overviews. Then, creating a hypothesis about what a model should do given the data. Next, pursue, that is, applying the hypothesized model over the data. Finally, verifying the model outputs qualitatively or quantitatively. Let's see an example of how this task model applies to the data preparation phase. Consider a scenario where a user is extracting aspects and opinions from reviews. First, users may view samples of reviews in spreadsheets. To understand data quality issues, they might cluster the review sentences to see if any patterns emerge. For example, presence of a different language or typos or HTML tags. Based on the observation, users may formulate hypotheses for cleaning the documents and define rules such as removing HTML tags and discarding non-English text. Then, users may pursue the cleaning scripts and finally verify the data quality to see if the hypothesis was correct or not. We found that this task model emerges across all the phases. More details are covered in the paper. Now, the tasks are so common, it might be beneficial to develop tools that provide support for these classes of tasks. We also observed that within each phase, the task model can be iterative. As we saw with the data preparation example earlier, users first explore the data to formulate a hypothesis and then confirm their hypothesis via a verification task. The exploration confirmation process is repeated until they are satisfied with the outcome. When we factor in the iteration among phases, the information extraction workflow becomes highly iterative, where users need to continuously context switch between various tasks and phases. Let's see the challenges introduced by the iterative exploration confirmation loops. So what are the exploration challenges? A key challenge is scale, which makes it difficult for the users to comprehend the data. Information extraction over text requires users to perform advanced search features which existing systems lack. For example, there is no default support for searching documents by parts of speech tag or synonyms of a word. Users often fail to draw insights due to a lack of context. For example, there is no interactive feature to show example sentence of each cluster in the earlier example that we showed. So what are some challenges related to confirmation? During hypothesis verification, qualitative validation can be challenging as existing tools do not automatically retrieve the source document of an extraction. For example, showing the sentences from which aspects and opinions were extracted. Similarly, there is no built-in support for comparing the outcomes of different extraction rules or decisions. For example, varying the size K of extractions output by different candidate models to compare their mean average precision. Finally, documentation can be tedious as users iterate over their hypothesis in the exploration confirmation loop. Iteration introduces additional challenges. Existing tools do not instrument provenance and metadata management as built-in features. Instead, they put the onus on the user to develop solutions for validation, documentation, and comparison across iterations. Another challenge is the lack of an end-to-end solution that support all the 5 classes of tasks. As a result, users may need to move back and forth between multiple tools such as spreadsheets, notebooks, and visualization dashboard, which is cumbersome. So how can we address these challenges? So we analyze the challenges from the lens of the cognitive engineering principles, which inform design guidelines for systems that involve human in the loop. We found that many of the challenges discussed earlier occur because existing tools do not adhere to these principles. Here are some examples we discuss more in the paper. Inspired by these challenges, we identified several design considerations for information extraction tools. Most of these are related to automating unwanted workload of users using an intelligent agent that may perform semantic search, generate automated summaries, or provide interactive feedback. We also recommend developing end-to-end solutions that support all the 5 classes of tasks: view, assess, hypothesize, pursue, verify for ease of use. Finally, provenance mechanisms should be incorporated to support the iterative information extraction workflows. In this work, we provide a fine-grained characterization of information extraction workflows using a task-based model, identify related challenges faced by the human in the loop, and propose design guidelines for addressing these challenges. While we focused on individual information extraction workflows, future work may focus on exploring how generalizable the task model is to other data science workflows. We also didn't explore the implication of collaboration on the task model, which needs further investigation. Finally, as we incorporate the design guidelines into practical systems, we need to consider the tension between human agency and automation.